Hello children, let us do an experiment to demonstrate osmotic pressure. We did osmosis last time. Now today we will be doing osmotic pressure. Now here you can see it is an experimental setup showing osmosis only last time what we did. Yes? Now what we will do today is here a piston with some weight on top is introduced through this funnel, through the stem of the thistle funnel. This is the stem of the thistle funnel. So a weight, that's called the piston, and having a weight on top is introduced. But when is this done? As soon as we mark the initial level of the sugar solution inside the thistle funnel. Then this weight, the piston with the weight is introduced through the stem of the thistle funnel, and this experimental setup is kept like this for some time. But later it will be observed that the level of water has not risen. What does it show then? It shows that no water has gone inside from the beaker. No water has entered into the thistle funnel. So what can be inferred is that we can say that osmotic pressure is equal to the weight or pressure required to nullify the nullify osmosis. That means, what is osmotic pressure? It is equal to the weight or pressure required to nullify osmosis. The osmosis also takes place with some amount of pressure. But if we put an equal weight on top, that will nullify the effect of osmosis, and osmosis will not take place at all. So this is the experiment on osmotic pressure. That means a pressure is applied from the top. It is exerted, and that nullifies the effect of osmosis. It will not allow osmosis to take place. It will prevent osmosis to take place. It will nullify osmosis. What will nullify osmosis? The weight given from the top. So we can say that now the definition of osmosis, osmotic pressure, definition of osmotic pressure is the minimum pressure that must be exerted to prevent the passage of pure solvent. Pure solvent is water outside. The passage of pure solvent into the solution when the two are separated by a semi-permeable membrane. Now there is one solution outside and inside, no? There are two, isn't it? Now they are separated by a cellophane paper over here. That cellophane paper is a semi-permeable membrane. So osmotic pressure is the minimum pressure that we have applied pressure from the top that must be exerted to prevent the passage of pure solvent. Pure solvent is water. The passage of pure solvent into the solution, sugar solution inside. When the two are separated by a semi-permeable membrane. That means, what is osmotic pressure? The minimum pressure that must be exerted, minimum pressure that must be applied to prevent the passage of solvent, pure solvent into the solution, that can prevent the passage of pure solvent into the solution when the two are separated by a semi-permeable membrane. Please try to understand this experiment. Very easy if you understand it. Yes, this is called osmotic pressure. You must know the definition. You must know the experiment. Now we move on to tonicity. What is tonicity? Relative concentration of the solutions that determine the direction and extent of diffusion is called tonicity. That means the relative concentrations of solutions. That means the concentration of the solutions that are there, say the two solutions that are there, and what concentration they are in. It will determine the direction and extent of diffusion that is going to take place. So that is called tonicity. So this is your definition of tonicity. Now, there are three types of solutions according to tonicity. Now the first one, look at this one. Now the blue dots represent water molecules, black dot the solute. Here you can see that this red is the cell membrane, and the cell within the inside of the red line. Okay, this red is the cell membrane. Okay, that means the membrane of the cell. What you can see is over here, the number of solute molecules and water molecules are more or less the same inside and outside. When it is like this, the number of water molecules entering and leaving the cell will more or less be equal. The net movement will be more or less the same. So when the solution inside and outside, they are of the same concentration, same number of solutes and solvent, okay, molecules are more or less equal, that time it is called an isotonic solution. Iso meaning same, having the same tonicity. Okay, concentration is the same inside and outside. Such a solution is called isotonic, and there will be no change as such in the cell also. Now we come to the next type of solution. Okay, here what you can see is the concentration of solute inside is more, black dots more inside the cell, whereas outside the solute concentration is less, and outside water molecules are more. So this type of and water moves now you know the definition of osmosis, it always moves from its region of higher concentration. So water will move from outside to inside of the cell. It will go from outside to inside of the cell. And this type of solution which has less concentration, that means solute concentration is less, so the concentration is lower than that of the fluids inside of the cell. Inside the concentration is higher. You can see the solutes inside. It's higher. So this type of solution is called hypotonic solution. And whenever there is hypotonic solution, what happens is water molecules, they will move from outside to inside. More water molecules will move from outside to inside. There will be a few molecules of water coming out from inside, but that's going to be very negligible, very less. But more water will be moving from outside to inside. Now when water moves from outside to inside of the cell, it is called endosmosis. Okay, water entering the cell. That leads to swelling of the cell. When the cell swells up, it becomes tight. That is called turgid. So hypertonic solution, endosmosis takes place and the cell swells up, and that is called the turgid condition of the cell. And this is how the cell will look, it swollen up and turgid after endosmosis takes place. Now we come to the third type of tonicity. Here it is a condition where water is more inside and less outside, and here the solution outside has a higher concentration. Lots of solutes outside, black dots, follow the black dots, lots of solutes outside. So, and less water molecules outside. Lots of solutes, less water molecule. Solution is of higher concentration, but water is more inside, and water always moves from its higher concentration. So what happens over here is water will move out of the cell, okay? There will be a few molecules of water going in, but more water will be leaving the cell. This is called exosmosis. And as water keeps coming out of the cell becomes loose, and that condition is known as flaccid condition. The cell will become more or less like this. The condition of the cell is called the flaccid condition. So hypertonic solution, when a cell is dipped in a hypertonic solution, solution outside is higher concentration. Hyper means high, okay? So hypertonic, more concentrated solution, when the cell is dipped in a highly concentrated solution compared to the contents inside. Exosmosis, water will leave the cell and the cell becomes flaccid. So the condition of the cell will be all shriveled up like this. The cell will look like this after exosmosis takes place. So I've told you about the three types of tonicity: isotonic, hypotonic, and hypertonic. Hypotonic, lower concentration than that of the fluids inside, higher concentration than that of the fluids inside. Okay, so hypo is always the term, the prefix hypo always means less. Hyper, the prefix always, wherever it is, it means more. Okay, higher, hyper, higher, high, more. Hypo, low. The prefix always refers to low. Okay, so just remember this: hypertonic, exosmosis, flaccid; hypotonic, endosmosis, turgid. Okay, now active transport. Active transport, what is it? It is the passage of a substance from its lower concentration. Okay, passage of a substance from its lower concentration to a higher concentration through a living cell membrane. But when molecules have to move from lower to higher, it requires energy. Okay, it requires energy from the cell. Okay, don't forget this energy part. This energy is required, and this type of transport, when molecules move from lower to higher concentration across a living membrane using energy from the cell, that is called active transport. Now the next one is passive transport. Passive transport actually is very much like diffusion, where molecules move from a higher region, whether region, highly concentrated region, to a less concentrated region, and requires no energy. So passive transport is like diffusion, requiring no energy. There is free movement of molecules from their higher concentration to their lower concentration. So actually passive transport and diffusion, they are very much similar. Okay, and active transport, it is just that it is moving from a lower concentration, the molecules, to a higher concentration, and they require energy. Okay, and how does it happen? Through a living cell membrane. I hope all is clear to you, and even if you have doubts, you can get back to me. Thank you. I hope all of you are keeping safe and keeping fine at home. And by the way, You have to do your projects. Please get back to me about the projects, okay? Do your projects. I've already given you the topics which you will have to cover. If you have any problem, please send a mail to me. Thank you.